Okay, so just checking over this first one, you needed to make a smart estimate. You could have done something as simple as 2 divided by 2, and you would know that your answer is going to be about 1. Okay, the model, I know I'm starting with 2 and 6 tenths, so I went ahead and shaded already, and I'm splitting it into 2 groups. So 2 and 6 tenths into 2 groups. Now there's different ways you can do it, but at the end, you need to make sure that these 2 groups that you split them into are equal. Okay, so I see now that I have 6 tenths, and so I'm going to do 3 tenths in each group. So that's group 1, that's group 2. So, and then the answer is how many in each group, and so I see that there are 1 and 3 tenths in each group. Okay, and I kind of know that's my answer. Like, I'm pretty confident with that. It matches my smart estimate. Now my model's done, but I'm going to go ahead and follow the rest of the steps, standard algorithm. So for this, I'm going to solve the problem 2 and 6 tenths divided into 2 groups. I'm just going to do it here. Okay, 2 goes into 2 one time. 1 times 2 is 2. Subtract, you get 0. Now, before you can touch the 6, you need to make the decimal jump. Okay, and now I can bring down my 6. It's safe. I will not fall into the recycling bin. 2 goes into 6 3 times. And if you needed to make your multiples, that's fine. So 2 goes into 6 3 times. And that is 6. Subtract, you get 0. Nothing else to bring down. So my answer, or my quotient, is 1 and 3 tenths, which matches my model. So far, I'm in pretty good shape since everything's lining up, my estimation, my model, my standard algorithm, and now I can check. And remember, it's kind of like if I make a capital C, 1 and 3 tenths times 2 better equal 2 and 6 tenths. So 1 and 3 tenths times 2, 1 place after the decimal, 0 place after the decimal. I hope my answer has 1 place after the decimal. And it equals 2 and 6 tenths. So 1 and 3 tenths times 2, and I counted the numbers on the side, and it should equal 2 and 6 tenths. And if you go back to the original problem, really what you just did was the inverse operation. 1 and 3 tenths times 2 better equal that. And so it all worked out. So you've justified or proven that your answer is correct. So this is like you are fully good with all parts of this. So that was number 1. Go ahead on to number 2.